Knowing before going. So before learning half equations, one must understand how to manipulate them. You must understand the difference between ions and atoms. You must know exactly how such atoms exist in nature. For example, some atoms exist as diatomic or even triatomic molecules. For example, chlorine in nature is diatomic. That's where you have Cl2. While magnesium is single. It is neutral. And magnesium in nature can exist as a carbonate or sulfate, but as a metal, it is just magnesium. You must know where you are going from and going to. Are you coming out of solution? Meaning, are you going from ions to atoms, or are you going into solution? Meaning, are you going from atoms to ions? And you must know what oxidation is and what reduction is. Example, Mg to Mg2 plus is oxidation. And they would say, a question would say, magnesium atoms are metal magnesium going into solution, and two chloride ions going towards becoming a molecule of chlorine is also oxidation. You realize it's going from a negative to a 0, so it's going up, so it's oxidizing. Oxidation means to increase in oxidation state. And so we have aluminum, 3 plus the aluminum metal, that is known as a reduction. And now we have some examples. So example, we want to go from magnesium ions to magnesium metal. Easy. So you go. Magnesium is in group 2, so it has the oxidation state of 2 plus. Anything that says ions, they have already been oxidized. We're going to become magnesium in the metal state, which is solid. The magnesium is aqueous when it is in its ion state. So we have gone from 2 plus to a state of 0, meaning that reduction has occurred. And since reduction is a gain of electrons, we know we have lost 2 electrons. So here you have. Once you have that plus sign, you know you have a plus here, so you're good to go. Now we're going to try chlorine gas. Right? The chlorine gas, as I said before, exists as a molecule. The molecules are all neutral. We have molecules like water, we have nitrogen, we write them here. So water is a molecule, it's neutral. Carbon dioxide is a molecule, it's also neutral. Nitrogen is a molecule, it is neutral too. So they wouldn't have a charge. Okay? And chlorine going into chloride ions means that you have Cl minus. This little number here tells us how many atoms make up that molecule, which is 2. So therefore you put the 2 here. Right? Awesome. So now we're going from a 0 state to a negative 1 state, which means that reduction has occurred. Right? Reduction has occurred. So therefore, if we go into negative 1, reduction is addition, so we're going to have 2 electrons. Why? Why do we have 2 electrons? Because 2 times this up here gives you 2 times negative electrons. Okay, now we're going from hydrogen ions to hydrogen gas. So hydrogen ions in group 1 most of the time, and we're going to gas. Hydrogen, like I said above, did I mention it? Oh, no. Hydrogen 2 exists as a molecule, a diatomic molecule in its natural state, so it has 0. So we're going from a plus 1 state to a 0 state, meaning that what? Reduction has occurred. And since reduction is the gain of electrons, we're going to add. We have 2 here. 2 atoms makes us put 2 here. And we're going to add. Got it? Because we have 2 atoms, we have to account for the 2 atoms over here. And since we have 2 times plus, we're going to have 2 times E minus 2 electrons. But we knew that it was going to be a plus anyway because we have a reduction occurring. So we're going from a plus 1 to a 0 state. We're in a reduction, so we have a plus here. We just had to work out how many electrons we'll be dealing with. And we got that from knowing how many atoms we have. Right? Remember, once you have to balance everything, balance the atoms, then balance the signs. And now this is the one that kills most people. We're going to go from hydroxide ions. And hydroxide ions, the decomposition of them is usually water and oxygen. And I didn't write my, so this would be aqueous, and this would be a gas. This would be aqueous, and this would be a gas. And here, this would be aqueous, this would be liquid. Water is usually either liquid or gas, and this would be a gas. Because you would see it's bubbling off at which electrode. Which electrode would this come off at? Let me know. So here we have this beautiful equation. Now we have 2 hydrogens, we have 3 oxygens, and we could probably put a 2 here. So now we have 4 oxygens, 2, then we have 4 hydrogens, so we could put a 2 or 4 here to account for our oxygens and hydrogens. And now we have a negative sign, and we're going from a negative to 0, so we're doing what? Oxidizing. And oxidation is loss, so we know that we have a negative sign here. And 4 times this will give us 4 electrons. And voila, we are balanced. Now remember, this always stays the same, and so does this. And these are the major ones that we deal with in electrolysis whenever it comes to very dilute solutions. All you have to do is remember these 2 and you're fine. Good luck.